Let's balance this equation as shown here. I rewrote the equation so that we would have more room to work. In this equation, we're going to divide down the yield sign and then count out our elements total. The trick with this problem is that you can use your prior knowledge about polyatomic ions and group things together. So before, in every other balancing equation, we only had each element alone and we were only counting each element alone. Now we can take elements together as a group. The only requirement that needs to happen is that these elements need to be in the same groups on both sides of the equations. So for example, here there's 1O and 1H on this side of the equation. There's 1O and 1H on this side of the equation. They appear in the same pairing. Just like on this side of the equation there's a CO3, and on this side of the equation there's a CO3. So they stay in the same groups. That means when we make our list and count up our elements, we can group them together. Again, we're going to start assuming one coefficient. So we have 1 Al here, 1 times 1. Then we can group together the OH. OH is 1 times 1 times 3. So there's 3 OH. Next, Li. Li, there's 1 times 2. 2 Li. Then we have the group CO3. CO3. 1 times 1. So it's only one CO3 group. I'm already counting this C in the CO3 group, so I don't want to count it twice. I don't want to go 1 times 3, oh, I have 3 CO3s. No, it's only 1 times this whole group. So I only have 1 CO3. Aluminum on this side is going to be 1 times 2, 2 aluminum. OH on this side will be 1 times 1 whole group, so 1 OH. Li on this side will be 1 times 1, 1 Li. CO3 on this side will be 1 times 1 times 3. So there's 3 total here. It's not 1 times 3 times 3. It's 1 times this one whole group times the 3 outside. Next, we have to play the matching game. Al is different, OH is different, Li is different, CO3 is different. Where do I want to start? Start with the easiest possible. In this case, I'm going to start with the Al first. There's 1 on this side and there's 2 on this side. That seems easy to fix for me. So I'm going to put a 2 in front of this Al. Now let's change everything on this side that I changed in the coefficient. 2 Al and 2 times 3 OH, 6 OH. So my Al is good. Next, I'm going to try changing the CO3s. I have 1 CO3 on this side and I have 3 on this side. I'm going to put a 3 in front of here. That means it's 3 times this one whole group. So I have 3 CO3s now. And I also have to change Li. 3 times 2. That means that there's 6 Li. I can move to the other side now. And I can change the OH. There's 6 OH on this side, there's 1 on this side. I'll put a 6 coefficient in front of this. That changes the OH to 6, but it also changes the Li to 6. Now my OH and Li match up, and my Al and my CO3 match up. Therefore, I'm done. These will be your coefficients: 6, 3, and 2. And if you want, you can put a 1 here, but you don't have to. This will be the answer for the balanced chemical equation.